Hello trainees, welcome to continue learning the HCI IoT courses. In the previous chapters, I introduced the knowledge in the network layer. We learned about common IoT communication technologies, including NB-IoT and 5G in wireless access scenarios, as well as industrial and home IoT gateways in wired access scenarios. In this chapter, I will introduce the knowledge in the platform layer to see what role the IoT platform plays in the IoT world. First, I will explain why the IoT platform is required in the IoT solution and describe the characteristics of the IoT platform. Next, I will introduce the functions and the services provided by the Huawei Cloud IoT platform. Finally, I will illustrate the development process based on the Huawei Cloud IoT platform. Let's start from the IoT platform. As I mentioned before, the platform layer is mainly used to collect data and manage access to the cloud by devices in the sensing layer. The IoT platform functions as a bridge between the upper layer and bottom layer. As the IoT continues to develop, it is necessary to build a secure, reliable IoT platform with open capabilities. After data passes through the platform layer, the data is directly presented to end users. The platform is the last barrier between data and users. In this course, you will examine what the industry expects from the IoT platform. I will also introduce the functional architecture, services, and the characteristics of the Huawei Cloud IoT platform in detail. First, let's see how the IoT platform develops and why the IoT platform is required in the IoT industry. This slide shows the three major challenges for the development of the IoT industry. First, long rollout period. There are a large number of manufacturers and merchants, and they focus on different applications in the IoT industry. If they all develop their own IoT applications, they need to build an ecosystem for all content in the IoT solution by themselves. This process would take a long time. This also causes application fragmentation. Every enterprise has its own application with incomplete functions. This also hinders product development since everything needs to be done from the beginning. Consequently, the product rollout period is prolonged, and the development of the entire IoT industry is slowed down. Second, there are too many standards in the IoT industry. The hardware in the sensing layer provided by various manufacturers use different protocols and standards. You can use a smart band as an example. To enable the smart band to implement different applications, we embedded several sensors into it. For example, we embedded an acceleration sensor and a gyroscope sensor for step counting. Sometimes we also embedded a temperature and humidity sensor and a communication module. These sensors may come from different manufacturers and use different protocols. We need to integrate them, but the integration process is quite difficult. In this case, we require an operating system to centrally manage all these devices. Third, network selection is also different. There are different types of networks, as we mentioned before. There is no best network, but the most suitable network for a situation. Different IoT devices use different network types, which may be 2G, 3G, 4G, NB-IoT, Wi-Fi, and so on. It is difficult to select a suitable network. After a network is selected, complex networking is also a headache. This is a great challenge for the platform because it must be able to authenticate device access over different networks. These difficulties create an urgent need for an IoT platform that can solve them with ease. The IoT industry has the following three requirements for the platform: device access decoupling, security and reliability, and capability openness. The first one is access decoupling. Decoupling is just like building blocks, but backwards. During decoupling, we split a big problem into several small blocks, and these blocks can be combined, replaced, and further split. And in this example, we treat device access difficulties that the developers faced as small blocks. Application developers only need to focus on their own application development, and other works can be left to the platform. The second one is security and reliability, functioning as a bridge between upper-layer applications and low-layer devices. The device platform must authenticate the access of both applications and devices. This use of virtualization technology in the cloud improves security while leveraging resources in physical devices. In the next, capability openness means that the cloud platform needs to be open. To accelerate IoT development, capabilities must be opened up so that enterprises in different scenarios can participate in the development.